Hello, my name is Mike Van Oudegem. Today I'm going to demonstrate a magneto generator. A magneto generator is a device that uses rotating permanent magnets in order to induce a electric potential in a coil of a conductor. Before we begin, let's review the science behind a magneto generator. This is Faraday's law of induction, also known as Lenz's law. It states that the time-varying magnetic flux linkage induces voltage in a conductor. As we see here, the induced voltage is equal to the opposite of the time differential of the magnetic flux linkage, where the magnetic flux linkage is equal to the product of the number of turns in a coil and the magnetic flux density. We can also see that the number of turns in the coil is directly proportional to the induced voltage. So to begin the demonstration, I'll talk about my generator here, my magneto generator. It's constructed of three main pieces. The first piece is called a rotor. It is the part of the generator that rotates. I made this out of a recycled plastic spool. I've glued 6 neodymium permanent magnets onto the spool with alternating polarity. The alternating polarity ensures that as the rotor rotates, the poles of the stator are always flush with opposite magnetic fields, and this generates the greatest difference in magnetic fields as it turns. The second piece of the generator is called the stator. This is a stainless steel U-bolt with 2 coils around it. Only 1 coil is required for a magneto generator to operate, but I made 2 separate coils of different geometries in order to demonstrate the effect of the different numbers of coils on the induced voltage. The first coil is approximately 200 turns of 14 gauge solid copper wire. The second coil is approximately 1,000 turns of 28 gauge magnetic wire. The last portion of the generator is the wooden cradle. This holds the poles of the stator almost flush with the rotating magnets on the rotor. To begin my demonstration, I've attached the probes of my multimeter to the leads of the coil with approximately 200 windings. And with this, we will see that we can generate a peak voltage of approximately 2 millivolts. For the next part of the demonstration, I've connected the probes of my multimeter to the leads of the coil with approximately 1,000 windings. Now, knowing that this coil has about 5 times as many windings, we can expect the induced voltage to be about 5 times greater than the last one. With the last coil generating about 2 milliamps, we can expect this one to generate approximately 10 milliamps. So let's test that theory. As we can see on the multimeter, our peak voltage is approximately 10 to 12 milliamps. So this confirms our guess, and it also displays it adheres to the linear relationship between the number of coils and the induced voltage. Now, magneto generators are commonly used in small engines such as chainsaws or lawnmowers or dirt bikes, where there's no other electrical system on the machine. They're also used in small piston airplane engines where they must be completely redundant from any other electrical system that might possibly fail. But they're useful and very common devices that we see across many parts of industry. Thank you for watching, and I hope you learned about magneto generators today.